inside the $1.5 billion foundation. This is how they built the world's tallest building.
The massive coil is loaded, and high-tech rollers guide the rebar. Programmable controls precisely
Aligning position 3.
Confirmed. Engaging clamps.
Extreme close-up. Dad.
Move the excavator to Sector 4. We need that concrete poured by noon.
Copy that, moving now. Set the bundle down now, easy.
We check the schematics. These spirals go into cage assembly next.
The reinforcement cage assembly is critical, aligning the vertical and horizontal bars precisely to the structural drawings.
Easy now, easy. Keep it centered. Watch the guides.
Copy that, coming down slow.
Verify the spacing here.
Spacers are secure, concrete cover is clear.
Final tie checks complete. We are ready for the pour.
Keep the flow steady, bring the vibrator down now.
Copy that. Moving to Zone 3. A little lower on the left. Okay, got it. All right, easy now. Keep it perfectly centered, slow and steady.
To support the world's tallest building, we had to go deeper. This billion-dollar foundation is the strongest ever built.
Alignment is spot on. We are perfectly vertical. Roger that. Millimeter perfect at the pile point.
The rotary head engages, the Kelly bar begins to spin. Vibration and torque build as the tool bites into soil.
Soil spoil lifts out in controlled buckets, then gets moved to designated bins. The workflow is clean and continuous.
Depth is increasing. The slurry is holding the bore steady.
Confirmed. Viscosity levels are optimal. Continue pumping at this rate.
Slurry flows into the bore, return slurry carries fine cuttings back. The loop is constant. Feed, stabilize, return.
The steel casing is lifted and set at the bore entrance. It rotates down with controlled force, guiding the drill perfectly vertical.
The massive steel casing penetrates the dense soil,
stabilized by the bentonite mud ring, creating the foundation for the world's tallest building. Close-up inspection. Tie wire twists are tight. Spacer wheels are evenly distributed to guarantee concrete cover.
The crane lifts the massive rebar cage vertically. It moves toward the bore like a key into a lock. A crew
Needs adjustment, shift west slowly. Roger.
Moving it now.
Hold it there. Perfect, lock the supports. All right, watch the alignment on that section. Make sure the seal is tight before we lift.
Tremmy joints lock with heavy clamps. Seals ensure no leaks. The pipe becomes a controlled channel for concrete placement deep below.
Easy now, keep it coming down slow. All right, she's clearing the cage. Send it down.
Concrete pours into the Tremmy hopper in a continuous stream. Smooth, consistent, no stops.
Tremmy management. As the concrete level rises, the Tremmy pipe is lifted gradually, always staying embedded on fresh concrete to prevent segregation.
Casing extraction. As concreting completes, the casing is rotated and withdrawn carefully.
Make sure all the contaminated material is out before the pour.
Roger that. Almost clear.
Connection secured on Geophone 3. Acknowledged. Data stream is green.
We need more ties on level 3. Crane, hold position. Foreman says we start the pour at 1600 hours sharp.
From the spinning drill head to the final integrity test, this is the vast pile grid anchoring the world's tallest structure.
Watch the alignment on panel 3. Keep the slurry levels consistent or we lose stability.
Slurry circulation maintains trench stability. Fluid flows in. Hydrostatic pressure vents collapse.
Watch the alignment on row 3. Copy that, adjusting now. All right, ease it down slowly. Watch the alignment. Lower away.
Concrete pours continuously into the Tremmy. Smooth, controlled flow replaces slurry from the bottom up. The wall panel.
Inside the $1.5 billion foundation. How they built the world's tallest building. Joint preparation between wall panels. Crews clean panel edges, remove debris and latents, ensuring the next pour bond. Dewatering system activates. Pumps remove groundwater continuously, keeping the excavation dry.
Keep it coming slowly now. Watch the edge over here. All right, moving to chute.
The scale here is immense. We're looking at thousands of tons of steel reinforcement being meticulously staged across the foundation mat.
Bottom mat reinforcement begins. Workers tie rebar grids methodically, spacing bars to structural drawings.
Lift it up, keep it steady. Watch your hands. Okay, set it down easy.
These vertical bars are coupled directly into the mat reinforcement, creating the structural continuity required to transfer the mat.
Bar spacing checks out and the tie quality looks solid. Confirmed. Anchor bolts are exactly to spec. We are good to pour.
All checks complete. We are cleared to commence the pour. Send the first load. Keep the pressure steady on line 3. We need a continuous pour. Don't stop it now. Keep it moving to the left. All right, bringing it up now. Watch the vibration.
Vibrators plunge repeatedly into the fresh concrete, eliminating air pockets and ensuring full consolidation around the rebar and anchor systems. Inside the $1.5 billion foundation, how they built the world's tallest building.
Monitoring system overview. Embedded sensors throughout the mat will track temperature, strain, and settlement during curing and throughout the building's life.